the History of the World podcast, written and presented by Chris Hasler. This is the History of the World podcast with me, Chris Hasler. And this is Volume 1, The Prehistoric World. Episode 8, The Ice Ages. Previously on the History of the World podcast, we have discussed the evolution of humans since the lines of the humans and the chimpanzees split from one another several million years ago. We have talked about the various species of hominins that have emerged and disappeared right up to our close relatives, the Neanderthals. We have also spoken about the technologies and capabilities of these animals and how they link together to result in the amazing evolutionary eventuality which is us. Hominins have existed on planet Earth for at least 6 million years. Over the course of that time, they have witnessed severe climate change. The temperature has fluctuated between warm and cold. The polar ice sheets have repeatedly expanded and receded. The oceans have risen and in turn lowered. Just what is causing this? How has it affected our evolution? Plus, how do we even know that this has been going on? In another special episode where we diverge from the chronology to investigate an important aspect of history and to gain a better understanding of the story in general, we are going to study the Ice Ages. Over millions of years, we have experienced numerous ice ages, periods of intense cold interlaced with periods of milder conditions. The last ice age started around 2.5 million years ago. But how on earth can we know that? Glacial erratics. Let us start our podcast episode on the Canadian prairies in the province of Alberta. We are about 5 miles west of a town called Okotoks, which is a Blackfoot name for a rock. The Blackfoots were natives to this part of North America before Europeans moved in on the area in the 18th century. The fact that Okotoks is named after a rock could be significant to the subject of our visit here. Where we are, 5 miles west of Okotoks, is a boulder. The boulder shouldn't be here though. The land around the boulder is quite featureless. The boulder weighs in excess of 16,000 tonnes, so there is no way that anybody could have put it there. So what is it, and what is it doing in the middle of the prairie? The first thing to establish is where the rock could have realistically come from. The rock itself is split into 2 halves, and it is predominantly grey, pink and white in colour. It is made from quartzite, which is a material that we have mentioned before associated with Paleolithic stone tools. The nearest possible source for such a rock would be from near the Athabasca River, but this is about 500 kilometres north of where Big Rock sits today, so it is really quite a mystery. The Blackfoots had their own legend for the story of the Big Rock and its journey. Their story involves a character called Napi. Napi was a trickster. He spent his time tricking all the creatures of the land and even cheated someone out of a nice buffalo robe which he decided to wear on a trek with his friend Coyote. Everybody was tired of Napi's tricks, so the sun and the wind decided that they would play a trick on Napi to teach him a lesson. The sun decided to shine brightly and make it very uncomfortable for Napi to continue wearing his robe, so his friend Coyote suggested that he give his robe to the big rock. So Napi gave his robe to the big rock as a gift. At this point, the wind took over and started blowing cold air, causing Napi to want his robe back. Napi went to the big rock to get his robe back, but the big rock said that it was a gift to me. Napi took the robe, simply believing the big rock would do nothing, because it was just a rock. What can a rock do to stop me? Nonetheless, the big rock actually started rolling after Napi, which caused Napi to panic and start running. Napi ran for miles and miles over the rivers and across the prairies. Napi appealed to the animals to help him, but they were all simply amused to see this trickster in trouble. Now, this is where the story becomes slightly ambiguous, with a few different versions of the outcome that I have stumbled across. One version suggests that it's the bats who decide to help Napi by breaking the rock apart, hence the reason why they have had squashed up faces ever since. Another version states that it was the swallows that helped him by farting on the rock and breaking it into two. But personally, this just sounds like something a facetious elderly Blackfoot native made up for his own amusement to impress some gullible youngsters. Whatever the story, it does explain how we now find Big Rock 500 kilometres away from its source and broken into two pieces. Now, if you're a geologist, the chances are that you are not going to buy into that story with a great degree of enthusiasm. You are more likely to be going and looking for something that can be scientifically substantiated. Initial scientific theories have suggested that a major flood of some kind caused the rock to be displaced, but that is quite difficult to envisage. Remember that we're talking about a few hundred kilometres here. Another theory was related to the work of a gentleman called Louis Agassiz. Louis Agassiz was a Swiss-American geologist born in the Haut-Vouilly municipality of Switzerland in 1807. Being from Switzerland, Agassiz was quite familiar with the mountainous terrain and was able to observe their geology. Agassiz was at around the age of 30 when he proposed the theory that the Earth had been historically subject to an ice age where large sheets of ice, referred to as glaciers, had encroached down across the land of the northern hemisphere. Agassiz and many other geologists decided to study glaciers more closely in order to establish some credence to the theory. Agassiz himself travelled to Great Britain and determined that displaced stone and rock demonstrated that Great Britain was once similar to Greenland, and that it had been subject to being covered by a glacier that had drifted, carrying rocks within it and displacing them further south than their original location. It is now believed that Big Rock is something that has been subjected to the same phenomenon. It was swept up by a drifting glacier from its original place at the Athabasca River. The glacier carried Big Rock southwards as the glacier extended across the North American continent. Ultimately, when the glacier receded, Big Rock was deposited onto the prairie and left behind in its new location far away. Agassiz is still widely respected for his original theories and has been remembered in the names of educational establishments and geological landmarks. Despite his very inspiring and groundbreaking scientific theories which are being supported by modern science, it is interesting to think that Agassiz spent his whole life opposing Charles Darwin's theories of evolution. Big rock is referred to as a glacial erratic. Erratics can be found in many locations across North America and Northern Europe, and they are all believed to have been transported by glaciers and indicate the extent of ice sheets that extended southwards during the ice ages. Geological evidence. So, to discover more about historical glaciation, it would be a good idea to look more at the rocks to establish more facts about the nature of glaciation. A lot of the glacial erratics show evidence of scouring and scratching, which are referred to as glacial striations. The striations demonstrate the direction of movement of the glaciers as they represent small pieces of rock scraping along other pieces of rock and leaving a striation on the surface. The thing that you notice about striations is that they tend to be parallel, so there is a clear direction in movement. The only issue with striations is that they tend to not be able to leave you with evidence of the last glaciation, due to the fact that each glaciation will create new striations and likely render previous glaciations somewhat difficult to see or interpret. Some glaciers will carry an abundance of material and leave it accumulated in one place where the glacier stopped before receding. A bit like if you shovel snow, you will create a mound of snow. So you can see on the landscape accumulations of unusual rock material that can create an artificial mound on the landscape. These are called moraines and can demonstrate a glacial maximum, the extent of a glacier's journey across the land. As much as this geological evidence is helpful, there is another form of geological research that can provide further evidence through chemical analysis. This is by taking core samples from sedimentary rocks, either from land or ocean floors, and even from existing glaciers themselves. The core is created by drills which extract long samples of the material, which date further back in time the deeper you drill down. Chemical evidence. As technology progresses, so does our ability to drill deeper and deeper into our ice sheets. Therefore, the collection of ice cores is an ongoing project. Places such as Antarctica and Greenland are the current preferred places of research. Cores taken from both ice and sedimentary rocks are stored away for research and examined for evidence such as fossils which offer clues to the Earth's history. Some very small animals found in these cores show evidence of altering their condition according to the contemporary climate. So by studying the chemical composition of these fossils, we can determine the climate of their environment. The depth of the fossil within the core correlates to the age of the fossil, so we can determine both the condition and the time. This is a great way of exploring those earlier ice ages which have been hidden from us on the glacial erratics by subsequent ice ages wiping away the evidence. Sometimes, just by discovering standard fossils and understanding the type of animal that we are looking at, we can use a bit of common sense to determine the kind of conditions that had to exist in that region at the time determined by traditional methods of dating. Collate all of this information and you can start to construct a history of the Earth's climate. Quaternary glaciation. The deep sea cores have been particularly helpful in mapping the climate of the world, and we can now tell the story of the last 5 million years, which fundamentally targets the time periods we have concentrated on during the first 7 podcasts, and will give us some good knowledge going into the next 3 podcasts in particular. The important observation is that climate change is quite erratic, with distinct variations occurring over any sample period of 50,000 years. Even if we go back 10,000 years from the modern day, then we will notice that we were in an ice age, so the climate was significantly different. We are currently in an interglacial period where the climate is warmer. However, there is a median that can be gathered, and over the course of the last 500,000 years, this median is around 6 degrees centigrade lower than the median from 5 million years ago. In brief, the world is on average colder now than it was 5 million years ago. So what happened? When you plot the core-derived temperature on a graph, you notice a significant average downturn in averages that begins to occur around 2.5 million years ago. This has come to be known as the quaternary glaciation and is still active to this day. Scientists speculate as to what caused this sudden change in the Earth's climate. Possibly it's something to do with the geophysical position of the continents and the oceans. Possibly it's something to do with the Earth's orbit. We do know that this situation feeds itself, as a glaciated Earth will reflect the sun's energy away from the planet, further exacerbating the cold climate and making it even colder. Whatever the reasons, the results are that glaciation and the creation of ice sheets and glaciers will more likely occur, and it is this phenomenon that will cause those conditions which will create these monstrous glaciers that will transport glacial erratics such as big rock and deposit them many miles from the place of their formation. Effect on the planet. So we've spent enough time talking about the science of ice ages. Now we need to discuss what part that plays in our story. So from the time of the Australopithecines, global climate started becoming an issue that Homo habilis, Homo erectus and Homo neanderthalensis have had to deal with in turn. They have had to adapt and evolve as a consequence of the quaternary glaciation. One fact that we know is that there had to be more available moisture on the planet 5 million years ago. The reason for this is that when glaciation is occurring and these huge ice sheets are formed, that they will lock up the moisture of the planet, leaving sea levels lower and less precipitation as a consequence. The Sahara Desert is a huge arid area in North Africa, and it is vast due to the fact that we are in the quaternary glaciation. However, if we go back 5 million years, we will find that the Sahara Desert would be much smaller. More plant life would have existed as more moisture existed. Desert lands would have been grasslands, and grasslands would have been rainforests. One of the very first human ancestor candidates that we mentioned in the very first introductory podcast was Sahelanthropus chadensis. Sahelanthropus lived near Lake Chad around 6 to 7 million years ago and was discovered in the Jurab Desert, which is a part of the larger Sahara Desert. There is probably no way that Sahelanthropus wanted to live in hot, arid desert conditions, so it is likely that the Jurab was not a desert when Sahelanthropus was alive. It was not a period of glaciation when Sahelanthropus was alive, and therefore there would have been more moisture in the Earth's atmosphere. Through geological research, we can feel confident that Africa would have had more trees and plants growing there, which would have suited their preferred arboreal lifestyle. Australopithecines would have also thrived in these rainforest conditions, enjoying the tasty vegetation being offered by the trees and plants. They would have also enjoyed the safety of trees, far above the dangers of predation that existed on the jungle floor. Sometimes we mistakenly assume that bipedalism is something associated with the floor, but there is no reason not to manoeuvre around in a bipedal fashion on large tree branches, so the fact that bipedalism had existed for a few million years before the Australopithecines evolved needn't be a big surprise, even if we want to assume that bipedalism was encouraged by the quaternary glaciation starting and the rainforests disappearing as a consequence. However, there can be no doubt that bipedalism certainly had its advantages when the Quaternary glaciation did start, and the Australopithecines were forced more and more to consider being on the ground for longer periods of time, because its habitat was slowly dying away due to the lack of moisture in the air being locked up in the polar glaciers. Even though we are talking about equatorial Africa, we are seeing direct effects on the biodiversity caused by activity in the polar regions. The Earth is certainly a small place when it comes to events that affect the climate. Human evolution. It may then come as no surprise that Homo habilis emerged at a similar period to the beginning of the Quaternary glaciation. While some will argue that habilis is an Australopithecine, the reasons why it is not is because it shows traits that we more commonly associate with humans. The study of prehistoric hominin diet is another one of those subjects for which we have had to make assumptions based on indirect evidence such as the fossilised bones of animals, hominin dental setup and stone tools, but it does seem that evidence points towards a more carnivorous diet at the same time as the emergence of Homo habilis, and also at the same time as the beginning of the Quaternary glaciation. If Homo habilis needed to start eating more meat, that would suggest a diet change, and a diet change should only occur if there is an environmental change, and an environmental change is often the product of a climate change. So it does appear to be quite convenient explanation of events. The rainforests of Africa started disappearing, and Australopithecines had to adapt to this, spending more time on the ground and looking for a diet that included more meat to overcome a possible lack of vegetation. The stronger Australopithecine survived and evolved into the Homo habilis animal. Those Australopithecines that did not become more carnivorous may have had to rely on the more fibrous produce of smaller shrubs and plants in the changing environment, and could have evolved to become the paranthropines, with their powerful jaws that enabled them to chew this more difficult to digest vegetation. Ultimately, though, we believe that these paranthropines, or robust Australopithecines as they are sometimes known, have simply died out, leaving the Homo genus to be the one to replace the Australopithecines. Expansion. The impact of the Quaternary glaciation would have caused the ice sheets to creep over the land in the northern hemisphere and would have made winter conditions particularly harsh in the areas between the tropics and the poles. On the face of it, it seems strange that it is after the Quaternary begins that hominins chose to migrate northwards into Eurasia. In fact, it may be the case that large populations migrated in and out of Africa according to whether there was an ice age or not. The pressures of having to spend more time on the ground due to Africa's loss of rainforests would have caused hominins to evolve rapidly from animals that were able to survive on the ground to animals who were experts at surviving on the ground. This would have involved the evolutionary ability to run on two legs, which is an important physical difference between Homo habilis and Homo erectus. It is possible that habilis evolved to become erectus. Whether or not it was habilis or a late form of habilis who left Africa first is debated, but Homo erectus was certainly an animal that is well known for living outside of Africa. Homo erectus migrated out of Africa due to the pressures created on its ancestors by the start of the Quaternary, and it migrated out of Africa in spite of the Quaternary taking place. The fact that Homo erectus is believed to have consumed more meat than its Australopithecine ancestors would have allowed the brain to develop enough cognitive ability for the tribes who migrated outwards to have the intelligence to adapt to to harsher environments and cooperate to be able to support each other through the tough winters. Homo erectus was becoming more and more able at creating tools and able to hunt larger animals due to the ability to move across the ground at speed. The tools that were manufactured would have successfully transitioned into Acheulean type tools from the more basic Oldowan type tools. Homo erectus may have at least possessed the ability to control fire to be able to stay warm and create light in an environment where the winter days would have been a few hours less than in equatorial areas of Africa. If Homo erectus was cooking its food using fire, then it would have been able to evolve its intelligence at a quicker rate and develop more resourcefulness to be able to become expert survivors in northern hemisphere conditions. The population of the world. So if we look at the population of the world up to the time of the Neanderthals, we believe that most of the African continent would have had hominin presence. The expansion of the Sahara Desert would have pushed any potential hominin population out of that area. We are unsure, however, whether a large area centred on the Congo Basin would have been populated. Incidentally, this is the same area where the chimpanzee populations of the modern world exist. There are 3 possible migration routes out of Africa. Firstly, the obvious one is via the Sinai Peninsula, which is a definite land bridge that links Africa and Eurasia via Egypt. However, there is a strait of water which connects the Red Sea to the Gulf of Aden, which also has to be taken seriously. The strait is called Bab el-Mandeb and is about 30 kilometres in width. Standing on the coast of Eritrea or Djibouti in Africa, you would certainly be able to see the land of Yemen on the Arabian Peninsula on the other side of the strait. When we talk about ice ages, we talk about polar glaciers locking in the moisture of the planet, and this will include substantial amounts of water from our oceans, causing our ocean levels to be much lower than we know today. Therefore, some believe that a land bridge may have existed at this point which allowed hominins to migrate directly to the Arabian Peninsula without the need to go to the far north of the African continent at Sinai. Certainly the expansion of the Sahara Desert into Egypt and Sudan would have made it difficult for hominins to survive if there were any distance from the Nile River. So all of these factors could bear relevance. Personally, I think the Bab el-Mandeb land bridge crossing sounds feasible. Hominins would have easily been able to see the land, and it may have been a relatively easy crossing during an ice age when the ocean levels were very low. The third option to leave Africa is at the Strait of Gibraltar, which is probably the most interesting discussion when it comes to hominins leaving Africa. The strait is way over at the northwest of Africa, so it is by far the furthest from the hominin discoveries which centre around the Great Rift Valley in the east of the continent. The crossing is around 9 miles wide, so it is smaller than Bab el-Mandeb, which by comparison is very close to the Great Rift Valley. When ocean levels were low, undoubtedly a resourceful hominin would have likely found a way to cross the strait, which leads to the Iberian Peninsula of Europe. In order for hominins to reach the Strait of Gibraltar, we would have to assume that the Sahara Desert must have been small enough to go around without dehydration of the hominins, or that the hominins would have made their way across the north coast of Africa from Sinai, which looks out over the Mediterranean Sea, and ultimately reach the strait. I will publish a map which illustrates all of the 3 possible routes, as a strong geographical knowledge may be necessary to envisage these possibilities just by listening. On the face of it, I wouldn't have thought this to be a likely route. Sinai is an obvious and undramatic crossing point. Bab el-Mandeb could be reasonable dependent on the sea levels and the hominins' ability to either be able to swim a bit or build a very basic raft if a land bridge was not available. Gibraltar seems to be unlikely due to the sheer distance and the fact that it hasn't closed for the last 5 million years, so some form of water crossing would have been necessary. A species of animal called Therapithecus oswaldi may hold a clue. Therapithecus oswaldi is an extinct species of gelada, which is a primate not closely related to humans. Records of its existence are located in Kenya, Ethiopia, Tanzania, and South Africa. All of these countries have been extremely relevant in our hominin history, so it is very possible that this animal was living alongside hominins. More importantly, this extinct gelada can be traced to Algeria and Morocco. These are countries on the Mediterranean coastline of North Africa. Morocco is the country directly south of the Strait of Gibraltar, so if this gelada was there, it would be reasonable for humans to be there too for similar reasons. However, there is a cave on the south coast of modern Spain called La Cueva Victoria in the municipality of Cartagena. The cave contains many fauna fossils. They include Therapithecus oswaldi, and they also include what has strongly been suggested to be a 1.2 million year old Homo erectus. If this is confirmed, then it surely demonstrates that hominins confidently crossed into Europe across the Strait of Gibraltar, either taking the extinct geladas or being followed or indeed following the extinct geladas. With this in mind, it seems entirely possible. Remember that our first chronological mention of hominins in Europe was when we discussed the possibly cannibalistic and tentatively named Homo antecessor, 1 million year old residents of the Atapuerca Mountains in northern Spain. It seems plausible that their ancestors crossed the Straits of Gibraltar when we consider all of the evidence displayed during this podcast. This is not widely accepted as of yet, but it's a fascinating discussion. The most recent 1 million years. If Homo erectus migrated into Europe, then it is quite possible that it may have become Homo antecessor, then Homo heidelbergensis, and then Homo neanderthalensis. Of course, we don't really know enough to be able to wager our livelihoods on any of this. It's like finding pieces of a puzzle and trying to find likely links. You may even have an entirely different opinion to me based on the information that I've presented during this podcast, and maybe even have your own knowledge of discoveries that conflict with this. If you do, I should love to hear from you. Neanderthals have been traditionally associated with Ice Age life. However, the reality is that Neanderthals lived throughout various ice ages and the subsequent interglacials, and their range extends to areas south enough to be unaffected by the ice sheet, so some populations would have lived a life likely not even encountering ice. Neanderthals had the ability to survive in the cold ice age conditions of Europe. During interglacials, they would migrate northwards onto the British Isles and into northern regions of modern Germany, for example. As the ice sheets expanded during an ice age, Neanderthals would have migrated southwards to warmer climates. Nonetheless, cold winters would have been a fact even during interglacials, so Neanderthals would have had to have adapted to this. Some point towards the Neanderthal anatomy, and as we mentioned in the previous podcast, the respiratory system and the nasal cavity of the Neanderthal were sufficiently adapted to enable its body to humidify cold air. Some argue that this adaptation is somewhat old and not a cause of the harsh weather conditions, but an advantage that had already evolved somewhat before the Neanderthal had even fully evolved. I like to look at the intelligence of the Neanderthal as its main survival ability. At the risk of sounding sensitive, I don't feel we give Neanderthal intelligence enough credit. Neanderthals would have made homes of limestone caves and undoubtedly controlled fire well enough to keep them and their families nice and warm. They were successful hunters, developing tools and tactics that would defeat even the largest of animals, enabling the best hunters to create some hearty, hot-cooked feasts, not just of meat carcass, but of vegetation as well. All of this nutrient-rich diet would have provided good energy for the Neanderthals to stay fit and healthy. Those that were not so fit and healthy would have been cared for by their family and not abandoned, as can be the necessary case with some of the Earth's animal species. There's no doubt that Neanderthals would have scraped clean the hides of their animal kills in order to create capes to keep their bodies warm, so a very prehistoric type of clothing. Introducing the Homo sapiens. In the next podcast, we will introduce Homo sapiens for the first time. Homo sapiens are us, and our success in populating the entire world so quickly is in part due to the effects on the planet that the ice ages have had, creating land bridges while glaciers were at their greatest extent, enabling us to reach every corner of the globe. We will look at these stories over the course of the next 2 or 3 podcasts. Well, it's been a bit of a long one this week, so I'll try and wrap things up quite quickly. I did receive a message this week from a nice chap called Aaron who lives near Kansas City. He said, amongst other things, I'm enjoying the podcast. Great job thus far. I'm on episode 7. My only criticism is the reverb chapter intros. Would prefer if the subject was introduced more conversationally. Subject matter is very interesting and not discussed nearly enough. Yeah, I get where you're coming from there, Aaron. A good introduction, a good strong podcast introduction is very important. And if you go to most of the podcasting websites, they will always recommend it. Your accent is a bit much at first, but it's also endearing. Thank you for that validation. I do worry quite a lot about my accent, so I appreciate the compliment. The Paleoanthrope timeline is a great lead up to ancient and modern history. I'm looking forward to where the timeline goes once humans are introduced. Sumerians, Babylonians, Egypt, or do you stay in the pre-civilization era? Well, Aaron, just for the benefit of all the listeners who are interested, the podcast will remain in the prehistoric era until about episode 23, I'm guessing. And then we'll move into the ancient period, and that will be another series of around about 25 podcasts. During the ancient era, we'll be tackling the cultures of Sumeria and Babylon, as well as the Akkadian culture and the Hittites, also another interesting culture. Egypt is one that will be introduced, as will Mesopotamia, during the final prehistoric podcasts. And we'll be tackling Egypt probably across about half a dozen podcasts, the ancient era, as it's such a complex and long-lasting ancient culture, and we should really give it the time that it deserves. But thank you so much for your interest, and hopefully, yes, we'll move into the ancient times with ease and have built up enough knowledge of the pre-ancient requisites of the world and be able to make that transition very smoothly. Anyway, thank you very much everyone for listening. I'm not going to go into too much detail about other stuff which I normally do, so because we've gone on for long enough now, so I'll leave it at that, and let's do this again this time next week. I'll look forward to it. Cheerio.
The History of the World podcast, written and presented by Chris Hasler. Please consider making a financial contribution by going to the historyoftheworldpodcast.com website and clicking on the Patreon link. Email the show at historyoftheworldpodcast@mail.com. And don't forget to join our social media at Facebook, Twitter, Instagram and Tumblr. See you next time.